Back to challenge number 1, continued, part 3. Open the project that you saved earlier named challenge 1, part 2. If you did not do the prior challenge 1, you will have to do those first, starting with the very first challenge number 1 lab project. Because we're going to do some major editing of tags and add some timers to our application. So if you do not already have all of that code done to add the timers and edits to, you're going to have to go back and do it and then come back to this point in the manual, which is roughly page 204, 205, 206, plus or minus a page. Now on page 203, I did discuss switching processors, which I did in a previous lab. In a previous lab, I switched from the L31, which has two RS-232 ports. I switched over to an L35E, which has a 100 meg Ethernet port and the RS-232 port that's limited to 38.4K baud rate. The primary reason that we did this was for you to be able to see the procedure. Now, ordinarily, you would not switch processors out in the field unless the customer was upgrading from an older processor to a newer processor for one of several reasons. One reason could be that they want a higher rev level. There are some controllers like the L20 which is not supported above, I think, version 13. And that has only two RS-232 ports. So they may want to switch to a processor that has Ethernet. So they can, we'll say, interconnect their enterprise or go to the connected enterprise. They may also want to switch because they want more I/O. In other words, they've expanded their processor to the maximum amount of I/O that it can handle, and they want to go to more I/O. Now, if you're still using the same processor, which 999 times out of 1,000, you're going to use the same processor all the way through these manuals, simply because we just don't run out and buy new processors when we like. Okay, before we make any additions to our Just for Fun project, and I interchangeably call them Just for Fun and Challenges, download it and go online with it in the run mode. This logic is advanced for someone at the beginner level and requires some review before we add more code. If you think back to the time when you first created this logic, the logic on the screen in front of you, remember we have two rungs here for each conveyor. This was the, well, actually we have a start system and we have a stop system push button that is for all of the conveyors. And then for each conveyor we have start and stop conveyor 1, start and stop conveyor 2, and so forth. This is the actual logic right here. All this logic up here was to allow you to be able to toggle an internal bit on, a non-IO bit, and have it go on and back off on its own to save you the trouble of toggling twice. And this offers some interesting code for you to work with and study. So really this is the code down here that we're actually working with. And here we have a start stop system push button. And when this bit is on, it enables these three rungs that each have a start and stop buttons for conveyor motors. And as you know, we were not using actual I/O. We weren't using module defined tags. And we had logic to simulate momentary contact closures by using timer timing bits to pulse another bit that we were using as a momentary push button. In this rung of logic, in your lab manual, it's showing rung 0, which is, let me click on it and get back up here to rung 0. We're looking at this rung right here. And I said increase the preset to 2000. Click on 200, type in 2000. That gives you 2 seconds instead of 2/10 of a second. Then toggle the Start System push button from your keyboard and watch the accum. Toggle this. When it times out, the false execution turns the bit back off, so it's self-extinguishing. Did you see it accumulate and the timer timing bit go to the on state, as well as the Start System push button in memory? Yes. Change it back to 200. Although I'm extremely familiar with this code, we're reviewing it for the learning experience. Open the program tags and select the Edit Tags tab at the bottom. So we go to Program Tags. First we expand Main Program, double click on Program Tags. We're on Edit Tags. Notice that none of the tags in this logic, as you left it, have been aliased to actual module defined tags or IO tags. That column is blank. Also, the alias for column is grayed out because you are online and you cannot alias existing tags online. Now we will revisit this view later after we have aliased some tags. Now you can create a new tag. Notice right here, this is not grayed out, alias for. I could create a new tag and alias it to a module defined tag or some other tag online. But once you created it and accepted it, you cannot go back and alias it online. You can create new and alias online. If you make a mistake, you cannot correct it. You're going to have to go offline to make the change. If there are any alias tags, they are left over from some other lab project and they should be deleted. This will not cause a problem and it is unnecessary to delete them. Your choice. I like to keep things nice and clean and tidy, so I say delete them. Okay, we saved our project. As you can see up here, well, it says in beginner L31, that's the name of the processor. But anyway, challenge 1, part 3, and then the first version of part 3. And remember, you can create your own process for naming your projects as you save them, so you can go back and find a particular point. We're going to close the tag database, and then we're going to go down to our actual conveyor logic and system logic, and then we're going to right click on any instance of the tag Start System push button. So there's one right here, and there's even one up here, Start System push button. It wouldn't matter which one we clicked on. Right click. We're going to delete this logic eventually. Edit. We can't alias it because we are online. So we're going to have to go offline, then right click on that tag, Edit Start System push button. Now we can alias it, and we're going to alias it to local 1i data. Let's see, what did we pick? In the manual on page 206, 207, I said let us pause here to elaborate on your module defined data types. That is, the IO that you are using if it is other than the 1769 IQ6XOW4 combo module. And I said you could skip this process if you are using that combo module. And I showed you two screen captures from the module defined tags. And I said on the left are the IQ6XOW4 input tags. Write your input memory location in the right column. Those tags in the left column, you will substitute for those on the left if you're not using. When you look at the input tags, local 1i data 0 through 5, in gray, those are the module defined tags if you're using the IQ6XOW4. And then the white column to the right of the column on the left, where it says use this column to write in the module defined tags that belong to your input module. Write those local whatever slot number I data 0 through 5 in that column. Whatever you're using for your 6 inputs, write those in right there. Likewise, on the right, you have 2 columns for output, one in gray and one in white. Write in the 4 module defined tags that you're actually using with the output module that you have. And you might want to duplicate this list on a separate sheet of paper to ease referencing it as you complete the remaining projects in this manual. In other words, write it out on a separate piece of paper that you can have right in front of you at every step in this manual, if you're not using the IQ6XOW4. If you find the cross-referencing too difficult, you might go back to the first section of this manual and create the digital field device simulator nomenclature tags. These are easier to use because they directly correlate bit by bit. IN00 points to the module defined tag that you are using for input 0, and so on. And then on the next page we have a chart of those substitute tags. And remember, on your digital field device simulator, if you have our device, they are marked IN 0 through 5 and OUT 0 through 3. Okay, continuing. We go down, we pick the alias, and we drill down to bit 0. Apply. Now notice that now it says start system underscore push button, and then it's alias to this actual IO. In any place that that tag is used in this logic, like right here and right here, it's going to edit any instance of that tag, start system push button. So that's why I say you can click on it anywhere you see it, although this is really where we want to work, because we're going to eliminate all of this logic up above here, and we're going to start with just this logic down below. This is the actual conveyor control logic. How many locations in your logic reflect the change that you just made to the definition of the start system push button? Well, I see one there. You won't see any in there. And you're going to see 2 here. So I would say 3 instances. In the offline mode, you are allowed to edit many things that you cannot edit online. One of those is, or one of these, is aliased tags. You can create a tag and alias it online, but you cannot alias or re-alias once you have created it. If you mess it up, you will have to save, go offline, fix it, download, and go back online. Or if you haven't used the tag in your logic, which is unlikely for what we're doing right here, you could delete the tag and then recreate it. For the sake of your exercising and editing features, for the sake of your exercising the editing features of RSLogix 5000 and your understanding of aliases, we will edit the tags directly in the database display. But before we do this, take one last look at the logic with which you will compare it after you've edited the tag names and aliasing. You will notice that one tag, start system push button, is already alias to a bit of a member of a module defined data type. You just executed that in the last step. Then on the next page in the manual, page 208, 209, something like that, it shows you all of the rungs that you currently have in your logic. Now I have, in the manual, I have the logic in front of you, 8, 9, 10, and 11. Those 4 rungs, I have them at the top in the manual. It really doesn't make any difference where they go. I probably told you to put them at the top and put all this other stuff at the bottom. And just so you feel like you're not getting cheated here, I will select rung 0, scroll down, I'll put my cursor here, and I will go Shift, select, and now they're all selected. Now I'm going to click there, I'm going to drag the whole shooting match down to the bottom and drop it right there. That's major surgery, folks. One mistake doing this and it's a hospital job for sure. So now our logic here looks just like your logic on page 208, 209, whatever it is in your lab project manual. Next thing we're going to do is we're going to edit motor conveyor 1. Why I picked that I don't know, but right click, edit, alias. We could type in LL for local. That gets us a little ways down the list. Now the list starts with local, so we didn't save any time there. But if we had tags that begin with A, B, C, D, E, F, G, then you got to scroll down to the L's to get to local. So local 1, O for output, data, and I believe we wanted bit 0. Let's see. Nope, we picked bit 1. I guess that makes sense. Now, I made a mistake. I could go back and do all this and click on 1, or I could just go dot 1 and I'm done. Remember, it is just text, so anywhere that you can edit the text is good. Okay, so alias motor conveyor 1 to local 1 O data 1 or output 1 if you're using the substitution tags, and output 1 is going to have been alias to whatever your actual module defined tags are. Repeat the process to alias motor conveyor 0, 2, and 3 to bits 2 and 3 respectively. So right click, edit, alias, drill down, local 1 O, 2 for motor 2, motor conveyor 3, alias. You can pause if I'm going too fast, but after you've been doing this for a while, it goes very quickly. Okay, so we've just aliased our 3 conveyor motors. Now I have you alias the stop and start buttons for system conveyor 1 and conveyor 2. I said in there, for now we are not going to start and stop conveyor 3 with switches. We could delete the logic for conveyor 3 or just leave it in the program and ignore it for now. Now that we have real I/O, we no longer need the logic for the timer instructions that simulated momentary contact closures. But first I'm going to alias these other push buttons. So stop push button. I'll do a few of these in front of you. Edit, base, alias. Drop down the list. Go to your module defined tags. This is an output. No, I'm sorry, this is an input. Local 1I data. And I'm assuming it's 1. Yep. Stop system push button, data 1. Apply. And then we go to start conveyor 1 push button, edit, properties, alias, local 1I data, bit 2 or input 2. If you're using the substitute tag, stop conveyor, edit, properties, alias, drill down, local 1I data. I'm just going to guess 3. Seems to be the convention that I'm holding to. Start conveyor 1, I'm sorry, start conveyor 2 push button, edit properties, alias, drill down, local 1I 4, apply, and then we've got stop conveyor 2, edit properties, alias, drill down, local 1I data 5. Okay, that uses up all of our inputs. We've only got 6 inputs, 0 through 5. We'll have to get clever later on when we want to include conveyor 3. So right now, these are internal bits, as we don't actually have I/O. In the manual, I said that we no longer needed that code, so delete all the rungs except the 3 below, plus the rung for conveyor 3 if you left it in. So that's 4 rungs. System rung, and then conveyor 1, conveyor 2. However, what I'm going to do is, because we have buttons to start system, I'm going to delete the start and stop for system, start and stop for 1, start and stop for 2. Oops, I got a little heavy-handed there. So edit, undo. Okay, start conveyor 3, stop conveyor 3. So I'm going to leave these in This is the one I meant to delete right there. I'm going to leave these in right here. Start button 3 and stop button 3 for these two. That way, if we want to run conveyor 3 later on, we can do it by right-clicking on these tags, toggling, and it toggles them on, then back off, or off, then back on, whatever we need. I'm going to close this. I'm going to save as part 301, because that was a major change, deleting that logic and aliasing all those tags. Now we're going to download and go online. By the way, having your toolbars spread around here like I've got them, that does make it a little harder to work with because you're accustomed to having them across the top. However, it does give you more space to work with over here in the ladder logic area. Download. This is Ethernet. That's why we kept the Ethernet processor, so you don't have to wait and watch while all of this slow business takes place. Change it back to remote run mode. Yes. Test your logic using switches, starting and stopping motors with system enabled and trying to do it without the bit set. Get both motors running and try the system stop. The system start was already on, and that is a toggle switch or push button. Now what we're missing here is we need input 1 on, because that's the stop push button. And remember that the stop buttons are normally closed, so we need to turn on 3 and 5. We want all the stop buttons to be on right now because we're simulating normally closed, so those bits would be on in memory and those instructions would be true. Okay, now we hit the button for start system. The system is enabled. Notice all the rungs are enabled. These 2 rungs here don't count. So let's, we can't scroll down to get these out of our sight, so we'll just have to ignore them. So it's the top 4 rungs that we're dealing with. Hit the start conveyor 1 push button. That would be 2. A momentary button starts that. Now you didn't see the button, but if I hold it down, now you see it go true. That's the nice thing about push buttons. You just a momentary push and you got it. Start conveyor 2 is 4, and of course this one, start conveyor 3, we have to toggle that if we're going to do that. Okay, so they all look the same. And remember, in the lab project manual, we're not using conveyor 3 right now. I'm just throwing in a few variations. Now we've got our basic conveyor control, and by the way, I said try the system stop push button, which is 1. If I turn that off and back on, it shut down everything. Challenge 1 continued, or part 4. Let's say that you want to lubricate the conveyor shafts every 12 hours of runtime, and you want to do it automatically. In other words, you don't want operator or human intervention. You want the system to know when the conveyor shafts have accumulated 12 hours of runtime, motion time in the bearings, and you want to lubricate the shafts. Furthermore, there are 10 points on each conveyor that need a push of grease lubrication every 12 hours of running time. The system shown in the manual, and that's, I don't know what brand that is, I just grabbed it off the web, pushes grease out through those, it shows 3 manifolds whenever air pressure is applied to the reservoir. And it's obviously what is the reservoir. We will need to control a solenoid valve by way of a timer to deliver the prescribed pulse of grease every 12 hours. That is, every 720 minutes, 43,200 seconds, or 43,200,000 one-thousandths of a second in logic engine terms. However, we are going to execute this logic. If we're going to execute this logic, we do not have time to sit around waiting for 12 hours minimum to see if our logic functions correctly. We will use 12 seconds instead of 12 minutes. Even I can wait that long. My attention span is at least 12 seconds, most of the time. Save your project, grease, and I'll make that a 2. We don't have to whoop, the name is invalid. Oh, I see what I did right there. Delete underscore 2. Now I don't know how long you can make that name. At some point it's going to complain if I keep making them longer and longer. You wouldn't do this out in the field when you save your project files. Whenever you go out to a machine on the plant floor or at the customer site, you always immediately upload what's in the machine and save it with a name that you recognize with today's date. And usually I'll call it green machine as is, and then I put in the date, and I might even put in the time, or I just put AM to show that I saved it in the morning when I got there. And then every time I make changes and save it, I give it a different name. That way, if I want to go back to what the customer had at the end of the day, in other words, I didn't get all my changes made, I can always download what they had to begin with, and it's right back to where it was. We saved our project with the word grease in it, and now we're going to go offline. Go offline. Mouse over the RTO, and that would be down here, and drag it after motor conveyor 1. So look at all of the instruction memes. Holy moly, look at all those little instruction memes going, pick me, pick me. Well, you got to be careful now, because if I let it go right there, do you see where it's going to go? Look for the green dot. It's going to go right after stop conveyor 3 push button. We don't want it there. So we go up here. If we let it go here, it's going to go conveyor 2. We want to go conveyor 1. So I'd bring it right up to the green dot and turn it loose. Earlier in this lab project manual, toggling meant using the keyboard to select tag, right-click, toggle bit. Now that we have our tags alias to real I/O, most of them, toggling means to either switch it on or switch it off, or both in the context of the logic. Use your switches from here on, with the exception of bits that do not have real I/O, because there are no I/O points left to assign to that bit. Now, if you just happen to be fortunate enough to have a digital field device simulator and I/O cards that give you more bits, well, great. You're welcome to use them. As a matter of fact, our digital field device simulator is limited to 6 inputs and 6 outputs, even though with the IQ6XOW4 you only have 4 outputs wired up. The 2 conductors for the other 2 lights and the pilot lights, the lit switches, they do go up to the swing arm. They're just not connected to anything. Now, when you have this digital field device simulator wired up to an IQ6XOW4, all the conductors laying on the same RTB, removable terminal block. But if you have an input card and an output card, then some of them go to the input card, some go to the output card. I think you know that. Okay, repeat for conveyor 2, creating the tags as shown below in the manual on page roughly 212, 213, and enter 12,000 or 12,000 thousandths per second or 12 seconds for the presets. Do not forget conveyor 3 if you have it. I never finished this one. Okay, so this would be conveyor 1 lube schedule timer. Okay, so and I'm going to abbreviate conveyor. I'm going to make it O1 though, not what you have. Conveyor 1 lube schedule. Okay, right click, new. We're in the main program, that's good. Create. You see that's a happy rung, but we need 12,000 for a preset. Now you could do this. I would tell you to drag over RTOs just for the experience. But you could also click here, Control C, click here, Control V, click here, Control V, and then go here and change the 1 to a 2. Double click, drag through the 1 and make it a 3. Okay. Right click, new, create. Right click, new, create. Okay, and it's already set for you, 12,000, accum 0. Now you see how fast that was? While you're learning this, I would do it the long way. And then you can take the shortcut later when you're trying to save time. Once you're really, really comfortable with the RS Logix 5000 developments platform for the Logix engine, by all means, get clever. Download and go online in the run mode with your 3 rungs. Download, waiting, waiting, download, waiting. Now in the manual I said download and go online in the run mode with your 3 rungs with stop push button in the on state, meaning that you want to make sure that the stop system and the stop push buttons, all of them, are true right now. In other words, they're true if off instruction, but make sure those bits are on in memory, because this is what it would look like at rest. With stop conveyor 1 push button and stop 2 conveyor push button in the on state and stop 3 conveyor 3 push button, toggle the system start push button on off. We're enabled. Now we can run the conveyors. Now we're going to operate this code, operate this logic. We already have the system enabled, as you can see, and timing is very important here when we start getting into more complex or more convoluted logic. This is not very complicated, but for you it might be at your learning stage. Toggle start conveyor 1 push button switch on off. And you see we have conveyor 1 running. Do the same thing for conveyor 2. Conveyor 2 start button is 4. That'd be the second one from the bottom, that push button. I have 2 lights on now on my digital field device simulator. I have output 1 and output 2. Do the same for motor conveyor 3, except that you're going to right click and toggle. And it's going to use this logic down here that we didn't delete for conveyor 3. Now you don't have to do conveyor 3 in the lab project manual, but eventually we will end up with 3 conveyors in our challenge when we start adding more and more logic to build up a quasi material handling application. So your online monitor should look something like the screen you're looking at right here. And of course, if you're watching the video on one screen, pausing, and then going to your another screen to do your logic, that's cool too. Both conveyors have run for 12 seconds, which is not what I meant to do. I meant to stop them. Told you to turn it on, I never told you to turn it off. Now in the manual it tells you to do that. So here's what we're going to do. These are RTOs, so I'm going to do the stop push buttons, which would be 3, 5, and then toggle this one. Okay, so we're back to no accumulation. Well, we have to clear these RTOs. Now we don't have any resets in here. What I will do is make that 0, make that 0, make that 0, and then I will go into the program tags and I will go to the timers right here. I'll go to the, well, I have to go into monitor tags and re-expand it. Select the done bit, go to conveyor 2 lube schedule timer, select the done bit, 0 enter, go to conveyor 3 lube schedule, done bit, 0 enter. Close that. Now you see the done bits are off and they're not accumulated. So what I meant to do was to turn that on, then turn it off. Okay, and I had 67.89, that which would be 6 hours if we were doing 12 hours, but we're just, it's 12 seconds, so it's 6.5 seconds. Then for conveyor 2, we're going to do 4, then stop. Then conveyor 3, we have to do it this way. Toggle bit, toggle bit. Our 3 RTO instructions operate against 3 instances of the timer data type, and the accumulate for conveyor 1 is 6.5 seconds, 1.5 seconds for conveyor 2, and not quite 2.5 seconds for conveyor 3. So you see, as the conveyors start and stop, this will accumulate the total number of seconds, minutes, or hours, depending on how long you make the preset, that they have actually been turning the shafts against the bearings, and then when you get to a certain point, we want to lube it. I said to bump each conveyor with a little more time. That's not necessary. We could do 4 and 5 again. So 4, 5, and we could do this again. Toggle bit, toggle bit. But what do we do to operate the solenoids when the timer data types have accumulated the 12 hours? In our little example, we're going 12 seconds. Let's add some more logic. I had you add the logic shown in the manual, creating and aliasing tags as needed. I realized that Pt3 output may have been used for the conveyor 3 tag, but we will borrow that output since we are not using it yet. I'm not using Pt3. Well, right here, for this motor conveyor I am. I'm going to have to borrow that. That means that I'm going to have to unalias motor conveyor 3 from that tag, which I cannot do online. See, I can't delete that. I'm going to go offline to make the edits. Well, first I'll save, then we'll go offline. And now we're going to add a rung after this RTO for conveyor 1 right here. We're going to add a rung. We click there and it drops down a new rung, and we're going to add a truephon, a TON, another truephon, and an energize output. For this, we're going to use the conveyor 1 loop schedule done bit, so I can go grab conveyor 1 loop schedule, drag it over here, make sure that's green before you let go. Then drop it and put .dn enter. And here, this timer is going to be conveyor 1 lube pulse. CONV01 lube pulse. Right click, new, send the main program, create, and we will put 2.5 seconds in there. 2,500 milliseconds. We don't need an accumulate, and then we need this tag. You can drag it over here now, let go, double click, cursor after, .tt enter. Then over here I'm going to put conveyor 1 lube solenoid, CONV01 lube SOL. And I'm going to alias that. You'll see in a minute why I'm doing this in this order, so I can explain something. We're going to alias that to bit number 3, even though it's already used. I'm going to go back here because I'm offline, and I'm going to edit motor conveyor, whoops, almost made a mistake, conveyor 3, edit the properties, and I'm going to make it a base tag. That's simple. Okay, now the reason I did it is to show you that at one moment in time there I had motor conveyor 3 and conveyor 1 loop solenoid alias to the exact same output bit, module defined output bit. Not going to hurt anything, except that we don't want when we pulse conveyor 1 lube, we don't want to turn on conveyor 3, so we did have to unalias it here to make this a base tag. So basically, in order to keep conveyor 3 logic in here, we leave it without any aliased module defined tags. Now repeat this procedure for the grease system for conveyor 2. Now I'm not one to waste movement, so I'm going to go put my mouse there. Select rung 2, Control C, put my mouse here, Control V. Took, copied, pasted. Now this is going to be conveyor 2 lube, so I put in a 2 there. And I'm going to have to put in a tube in all these. That's easier than dragging them over and changing the bit. I'm going to go here, right click, new. It's in the main program, hit create. This, however, I see, for conveyor 1 I did use bit 0. So my apologies. Easy enough. Go back here to edit 0. Because I was thinking that whole time, why did I not use bit 0? So this is conveyor 2 lube solenoid, and we're going to alias that, new, alias, scroll down, and we're going to make that bit 3. This is good, but something is missing. What happens when the lube schedule timers time out and the pneumatic system has finished pulsing the grease reservoir and the RTOs do not reset on a true-false rung transition? That is correct. We need logic to reset the timer data types for the RTOs. We're going to add a couple more rungs. Normally you would add them right after. For conveyor 1 you would keep all conveyor 1 in one location. We'll do that. We pick our lube solenoid and then we click on a new rung, and then we need a true if on and we need a reset. This done, the pulse done, not the schedule done. So you gotta be careful what you're doing here. We'll reset conveyor 1 loop schedule. Okay, the reason we use the done on this and not this is because if we reset this timer with this done bit right here, this timer will only run for 1 scan, and then since we reset that RTO, this is no longer done. We won't get our pulse of lube, so we have to wait till this timer is done. The actual pulse on the reservoir, the pneumatic pressure to push the grease out there, when that pulse is done, then we can reset. So click on that, Control C, go down here, Control V, and we simply change that to a 2, and we drag down conveyor 2 loop schedule to there. Now we do want to do motor 3 as well. I will click on those 2 rungs, Control C, click on the rung that runs conveyor 3, Control V. This is going to be conveyor 3 loop pulse, which is not a tag, but now it is. So now we can change the 2 to a 3 and it will be okay. See, when you see the reverse video like that, RS Logix 5000, it says, yep, I got a tag by that name. So here we change the 2 to a 3. Immediately you see the reverse video. That means it's good. And then this would be conveyor 3 loop solenoid, which of course is a new tag, and we're not going to alias it because we don't have any more I/O. We have no more outputs to use. Here we just change the 2 to a 3, and here we change the 2 to a 3, or we could have just dragged down this tag name to here. We've got all 3 conveyors done. Test your logic, start conveyor 1 and watch the 2 timers. We can't watch everything at once, so we'll go back up here. System is enabled. Now watch what happens when this gets to the end of the 12 seconds. So we're going to turn on, we're going to start conveyor 1. Okay, I'm going to save this. You see that update firmware? Don't go anywhere near that. You do the wrong thing with that button and keep going with the directions, you could turn your hardware into a piece of junk. Seriously. So back up here to conveyor 1. Now we're online. Remember, we went in and out of the program mode back to run, so we dropped out this bit. Remember when we did OTE versus latch and unlatch? So we push this button to get system enabled, and then we push this button to start the conveyor. Watch what happens when it gets to 12. Watch this timer right here. Get a 2.5 second pulse on the lube, then this starts over again. And every 12 seconds of runtime on that conveyor, you'll get a 2.5 second lube pulse. See? Now if I stop that button, whoop, wrong one. So I stopped it right at, 10,311 thousandths of a second. Okay, I stopped it. Normally on material handling systems, you don't just turn on every conveyor in the joint and let it run. First of all, if there's nothing to move, then why waste the energy? Why waste the power? If there's a carton or an object on the conveyor and it gets to the end of the conveyor and then runs into something like a stop, there's stops that pop up between the rollers or at the end of the conveyor to stop cartons or objects from continuing, and the conveyor sits there and just rubs the bottom of the box continually for hours. Well, that's another problem altogether. So conveyors start and stop all the time. As you'll see later on in this manual, when we start adding more logic to our 3 conveyor system, you'll see that they start and stop for all kinds of reasons. Now, let's go ahead and try conveyor 2. We'll start it with input 4. We've got to have input 5 on. That's our stop push button. So we hit the start push button. We stop it. Then we'll go down here and we'll start conveyor 3 and stop it. So see, they all have different times accumulating. So let's go start them all and let them run. So we want input 2. There's conveyor 1, conveyor 2, and I'll start conveyor 3. So now notice, we'll move down here so you don't see the system, but you see all this logic. You got 3 rungs per conveyor. And right now you should see lights going on and off on your digital field device simulator, which would be outputs 1, 2, and 3. And every once in a while output 0 goes on, because remember, we had to use output 0 for the lube. So we've got 1 and 2 are conveyors, 0 and 3 are lube. But you can see all this logic is running independent. So it really doesn't make any difference what conveyor 2 is doing. It has no effect on 1 or 3, or vice versa. And you can see they're all 3 on right now, but they're not all at the same point. We may stop conveyor 1 and the other 2 keep going, and then when conveyor 2 is empty, we can stop conveyor 2. And then when conveyor 3 is empty, we can stop conveyor 3. That is if we're doing this manually. Remember, we're headed for automation here. But whenever you are designing a control system, almost invariably, you will need a manual control system as well. In other words, in the manual mode, you will need to be able to start and stop the conveyors for testing, adjustment, maintenance, whatever. Now, you don't see any of that yet. We don't have auto mode, manual mode programmed in here. This is a simple 3 conveyor system, and we've already got 3 rungs per conveyor, so to speak. We have the rung that actually runs the conveyor, and then we've got the lube solenoid rung, and then we've got a reset for the lube timer. If you still have logic for conveyor 3 that is using bit 3 of the output word, you will see erratic behavior. Now we unalias that so you don't. You shouldn't. If so, you will have to delete the rung or give the output a different tag. You can see that the logic for one is independent for the other. These programs scan top to bottom, left to right. Now let's go look at our main program, properties, monitor. Hey, looky there. Now we're up to 30 microseconds. So we added all this logic, We've increased the scan time. We were at 20, now we're up closer to an average of 30 microseconds. Rung 0 is going to execute, then rung 1, then rung 2, rung 3, 4, 5, 6, 7, 8, 9, 10, and 11. And then it'll start over again in the continuous task. See the clockwise swirly over here? Over here? Main task, clockwise swirly, continuous task. There are more things we could go look at. Now if we go to main task and go to properties, we can monitor it. And you see that we have milliseconds now, not microseconds. But you see this is 86, 88 microseconds. If you move the decimal place over 3 places, right there, you've got microseconds. Interval times, elapsed time between triggers. So we'll leave that alone, but it's there to look at. Don't get your head into that. Not yet. That's more like volume 3 or 4 of this series. This is just volume 1. Sufficient to the day is the evil thereof, or I should say sufficient to the day is the complexity thereof. I had you write up a synopsis of how this system functions, putting it in sequence of execution. Oh, so we'll do that. Well, first of all, you have to have the system enabled. Okay, so let's, just for grins, there's conveyor 1 running, there's conveyor 2 running, and here we have conveyor 3 running. They're all running. If we do the stop system push button, everything stops. Okay, because the rungs that control the motors have a condition right at the front of the rung, system enabled. If the system is not enabled, then the rung goes false. And if this is false, then this can't time out, be done and do this business, or this be done and do this business. All the rest of this logic, you have it in groups of 3. If the system is enabled and you start it, the motor runs, and we have a retentive on timer that will accumulate the actual time that this bit is on. And when it's on for 12 seconds, the timer times out, it's done. It starts another timer for 2.5 seconds, of which the timer timing pulse energizes the lube solenoid. And when the timer timing pulse or this pulse is done, then it resets this timer. So this is false, resets that timer, clears, everything stops. Well, that's about it. So save your project. So file, save. If you don't upload the data table values, then you don't retain any changes you made to presets or existing accumulate values. Now the accumulate values probably are not very important, but think about this. You're online and you adjust your presets for exactly what you want. Then you go offline, but you don't save your program. You don't save the data table values. Okay? You just save the program and it go offline. Then you make changes and download them. You may lose your presets.